Okay student, now let's move towards the question number 1 of today's lecture. 2x raised to the power 4 minus 11x square plus 5 equal to 0. We need to solve this equation, and to solve these kind of equation we suppose let x square equal to y. So x raised to the power 4 equal to y square. Now our reducible equation into general quadratic equation form is 2y square minus 11y plus 5 equal to 0. Now student, you can solve using factorization or completing the square method or quadratic formula. Here I use factorization. So for middle term breakup, our first term is 2y square and constant term is 5. So if we multiply these terms, that is 10, 2 5 are 10, and minus 10 multiplied by minus 1, that is equal to 10. And if we add minus 10 minus 1, that is minus 11, this is our middle term. Okay, now let's move. Take 2y common from 2y square minus 10y and minus 1 common from minus y plus 5. So we will get 2y minus 5, 2y minus 1 or y minus 5 equal to 0. Now either y equal to half or y equal to 5. So we suppose x square as y and x square equal to 1 upon 2 because we have y equal to 1 upon 2. So if we solve this equation taking square root on both sides, that is x equal to plus minus under root 1 upon 2, which is equal to plus minus 1 upon under root 2. Now again x square equal to y and other value of y is 5. If we take square root on both sides, that is x equal to plus minus under root 5, and our solution set is plus minus 1 upon under root 2 and plus minus under root 5. Dear student, this is a 4-degree polynomial equation. That's why we get 4 possible solution. Okay student, now move towards question number 2. So solve the equation 5x raised to the power 1 upon 2 equal to 7x raised to the power 1 upon 4 minus 2. To solve this equation, uh, let x raised to the power 1 upon 4 equal to y, and if we take the square of x raised to the power 1 upon 4, that is x raised to the power half or 1 upon 2, which is equal to y square. Now our reducible equation into general or standard form of quadratic equation is 5y square minus 7y plus 2 equal to 0. Now you can solve using factorization or completing square or quadratic formula. I use factorization again. So 5y square minus 5y minus 2y plus 2. So 5 multiplied by 2, that is 10. And if we add these number, because we need negative sign, so minus 5 minus 2, that is minus 7, and which is our middle term coefficient minus 7. Now take 5y common from y, 5y square minus 5y and minus 2 from minus 2y plus 2. So we will get 5y minus 2 and y minus 1 equal to 0. Now either y equal to 2 upon 5 or y equal to 1. We have suppose x raised to the power 1 upon 4 equal to y, which is equal to 1 value of 2 upon 5 of y. So we need to find the value of x we take power 4 on both sides, so we get 2 upon 5 raised to the power 4, which is equal to 16 upon 625. 5 raised to the power 4 equal to 625. Now again, x raised to the power 1 upon 4 equal to y we have supposed in first step, and it is equal to another value we get, which is equal to 1. And if we take 4 power 4 on both sides, so we will get x equal to 1, and our solution set is 16 upon 625 comma 1. Okay, now let's move towards question number 3. Solve the equation. You can see that question on the screen. Use same technique. Let x raised to the power 1 upon 3 equal to y, and if we take square on both sides, that is x raised to the power 2 upon 3 equal to y square. So put these values in our given equation. So the reducible equation into standard or general form of quadratic equation: y square minus 15y plus 54 equal to 0. Now solve using factorization or completing a square or quadratic formula. If we use factorization, now middle term breakup, so coefficient of y square is 1 and constant term is 54. So we need to find 2 factor of 54, which is 6 nines are 54, or if we add these number with negative sign, that is minus 15. Now y square minus 6y minus 9y plus 54, that is the middle term breakup form. So take y as a common from y square minus 6y, and take minus 9 common from minus 9y plus 54, that is y minus 6. So we get y minus 9 or y minus 6 equal to 0, either y equal to 9 or y equal to 6. So we suppose y equal to x upon 1 upon raised to the power 1 upon 3. So x 1 upon raised to the power 1 upon 3 equal to 9, and taking cube on both sides to find the value of x. So we get x equal to 729. Again, x raised to the power 1 upon 3 equal to y equal to 6. That is the second value of y, and taking cube on both sides, so we get x equal to 216. The cube of 6 is 216, and our solution set is 216 comma 729. Okay student, now last question of this lecture. Solve the equation 3x raised to the power minus 2 plus 5 equal to 8x raised to the power minus 1. Again, same technique. Let x raised to the power minus 1 equal to y. So if we take a square on both sides, that is x raised to the power minus 2 equal to y square. So our reducible equation into general or standard form of quadratic equation is 3y square minus 8y plus 5 equal to 0. Student, you can use factorization or completing a square method or quadratic formula. So using factorization, middle term breakup, the coefficient of y square is 3 and the constant term is 5, that is 15, and we need minus 8 in a middle term. So if we add 3 minus 3 with minus 5, that is minus 8. So take 3y common from 3y square minus 3y, and take minus 5 common from minus 5y plus 5. So we get two possible factors, 3y minus 5 and y minus 1 equal to 0. Now either y equal to 5 upon 3 or y equal to 1. So we have supposed x raised to the power minus 1 equal to y 5 upon 3, and y x minus 1, it is the reciprocal of 1 upon x. So our solution is x equal to 3 upon 5. Again x minus 1, x raised to the power minus 1 equal to y, which is equal to 1, and the reciprocal of 1 is also 1. So our solution set is 3 upon 5 comma 1. Okay student, now it's your turn. Try yourself the following questions. I have given you the hint and possible answer of these questions. Hopefully you understand this lecture. Thank you. If you like this video,